Welcome back to EtherLink AI Insights. I'm Alex, and today we're diving into something that's reshaping how enterprises operate, especially in innovation hubs like Tampere. We're talking about agentic AI and multi-agent orchestration, basically how companies are moving from chatbots that answer questions to AI systems that actually get things done. Sam, this feels like a pretty fundamental shift in how organizations think about AI, doesn't it?
Absolutely. And what's interesting is the data backs it up. According to McKinsey, 73% of enterprises now prioritize autonomous AI agents over traditional chatbots. We're not just talking about incremental improvements. Organizations are expecting productivity gains of 25 to 40% by 2027. That's a massive reframing of what AI can do in the workplace.
That's a huge number. So when we say agentic AI, what are we really talking about? Is this just a fancy term for better automation, or is there something fundamentally different happening here?
It's genuinely different. Traditional AI deployment treats language models as passive tools. You ask a question, you get an answer. Agentic AI flips that. These systems make autonomous decisions, integrate with your existing tools and databases, reason through multi-step problems, and maintain context across entire workflows. They're less like a helpful assistant and more like an actual team member with agency.
I love that distinction. Let me ground this with a concrete example. Say I'm running a healthcare organization in Tampere. What's the difference between a chatbot and an agentic AI system handling appointment scheduling?
Night and day. A chatbot answers, "Here are your available slots." An agentic system actually books the appointment, sends reminders, optimizes slot allocation based on clinical needs, handles cancellations, and adjusts the schedule in real time. It's not waiting for a human to take the next step. It's executing the entire workflow autonomously. All of that happens within governance frameworks and control systems that keep everything auditable and compliant.
That's powerful, especially in healthcare where compliance is non-negotiable. You mentioned control systems, and I think this is where things get really interesting. Because managing one AI agent is one thing, but what happens when you have multiple agents working together?
That's where control planes become absolutely critical. A Forrester study from 2025 found that 64% of enterprises running multi-agent systems experienced governance failures without centralized control. In regulated industries like healthcare or finance, those failures carry serious legal and reputational consequences. You need a control plane that routes requests to the right specialist agent, allocates resources efficiently, maintains audit trails for GDPR compliance, and knows when to escalate to a human.
So the control plane is essentially the conductor of the orchestra. It's making sure all the agents are playing in harmony rather than stepping on each other's toes.
Exactly. Without it, you get fragmented decision-making, accountability gaps, and costs that spiral out of control. Think about a healthcare organization with a billing agent, a clinical agent, and a compliance agent all operating independently. They don't know what each other is doing. The control plane solves that by coordinating them transparently while maximizing autonomous throughput.
And you mentioned something called MCP servers, Model Context Protocol. How does that fit into this orchestration picture?
MCP servers enable agents to share knowledge, tools, and context without redundant prompts. Imagine a distributed team across different time zones. One agent documents decisions, another implements them, a third evaluates outcomes. Instead of them all repeating the same context to each other, MCP creates a unified protocol where they can coordinate seamlessly. It's efficiency at scale.
That makes sense. Now, I want to shift gears a bit because the blog post also emphasizes small language models, SLMs, and their role in this ecosystem. Why would enterprises choose smaller models when larger ones exist?
Cost and privacy primarily. Large language models are expensive to run, and they often require cloud deployment, which creates compliance headaches in regulated industries. SLMs can be deployed on edge devices or on-premise infrastructure, which means faster response times, lower latency, and crucially, your sensitive data stays private. For healthcare in Tampere, that's huge.
So there's a strategic composition here. You're not replacing large models entirely. You're using them where they make sense and routing simpler tasks to SLMs.
Precisely. The control plane becomes a smart router. Complex reasoning tasks that require deep understanding go to your large models. Straightforward decisions, data retrieval, and routine workflows go to SLMs running locally. You optimize for both capability and cost. That's how enterprises achieve real ROI on their AI investments.
Let's talk about the real-world application here. If I'm a Tampere enterprise, maybe in manufacturing or healthcare, how do I actually start building this? What's the first move?
First, audit your existing workflows. Where are humans wasting time on repetitive, multi-step processes? That's your target for agentic automation. Second, map your data flows and identify what needs to stay secure. That tells you where to deploy SLMs versus larger models. Third, design your control plane architecture, governance, audit trails, escalation logic. Don't skip this step.
And I imagine that's where specialized consulting comes in, especially in compliance-heavy industries like healthcare.
Absolutely. Organizations like EtherDev specialize in architecting these systems for compliance-heavy environments. They understand EU AI Act requirements, GDPR implications, and the specific regulatory landscape in Finland. That expertise matters because getting orchestration wrong in a healthcare setting isn't just inefficient, it's dangerous and legally risky.
Before we wrap up, let me ask you this. What's the biggest misconception you're seeing about agentic AI and multi-agent systems right now?
That it's primarily a technology problem. Organizations think they need the fanciest models or the most sophisticated orchestration tools. The real bottleneck is usually organizational design, aligning how agents operate with how your business actually works. Technology is the easy part. Governance, human oversight, and change management are where enterprises stumble.
That's a sobering reminder that AI implementation is as much about people and process as it is about code. Sam, thanks for walking us through this. For our listeners in Tampere and beyond who want to dive deeper, we've got the full article on etherlink.ai with all the specifics on AI lead architecture, control plane design, and practical SLM deployment strategies. Check it out, and thanks for listening to EtherLink AI Insights.
Thanks, Alex. And if you're running multi-agent systems or thinking about it, take that control plane design seriously. It's the foundation everything else rests on. See you next time.